Hello, good morning, good afternoon, everyone out there, depending on which time zone you're in. Welcome to the What's New in Tesira 3.17 webinar. My name is Kris Daily, Applications Engineer here in Beaverton, Oregon, and today is October 19th, 2020. I do ask, give you guys a picture here. This is me. I've been with Biamp for just over 5 years now. As far as our agenda today, we've already knocked out introductions and housekeeping. We're going to go through the new features, namely Parley microphone and AEC enhancements, TTM-X mute button logic, there's a new change there, and Tesira Software improvements, and then EX-UBT HID improvements. You'll notice the screen capture on the right is actually a direct capture of what you received via email, a little more verbose in the explanations, but same itinerary that we're going to run through here. So to start off with Parley Mic and AEC enhancements, if any of you were in the May presentation for what's new in Tesira 3.15, you might recognize this content because it is identical. So to give you a little background there, with 3.15, these improvements, enhancements were made for the Forte. So when Parley microphones were paired with the Forte platform, the enhancements were added then. And then with 3.17, those same changes were actually imported into the server and server IO. So our larger chassis and larger systems. So as of 3.17 now, both platforms have the same improvements when it comes to AEC and Parley microphone. So what are those? So beam tracking performance on the Parley series microphones is actually tighter now and is better at locking to the active voices. We've also improved activity detection, so it detects when a person is no longer talking and actually turns off or disables the beam, so as not to pick up excess noise there. Also, we've got improved handoffs between the different beams. So if you have multiple talkers around an array or a pendant, it hands off between those beams more smoothly. So this is helpful when you have multiple talker scenarios. We've also improved the tracking in the elevation plane. So if you have a TTM-X, a ceiling mounted microphone, this is the down angle from the ceiling. It's a little bit better behaved and tracks a little bit better based on the target, the talking target in the room. If you have a TTM-X, then your elevation plane would be upwards from the table that the TTM-X is sitting on. We've also enhanced rejection of tracking of noise sources. So the infamous crinkling of chip bags and clanking of silverware during meetings that are lunch meetings, we're going to reject that a little bit better than we did before. We've also improved NLP for long echo tail length calls. So these improvements were all part of the process, part of the learning process and earning the Microsoft Teams certification. During that process, there's a long echo tail length test, which was actually one of the hardest tests that our DSP team actually had to work on to succeed in and achieve the certification. But the way that works, AEC, acoustic echo cancellation processing within Tesira, is a given tail length window. And once that tail length is processed, if you have any echoes that actually show up outside of that tail length window, then NLP is actually what I call the cleanup guy, or the cleanup algorithm that handles that if the AEC missed it or it was outside of the tail length. So NLP has been improved for those long echo tail length calls. Side note here, there's actually a minor difference between the Forte AEC and the server IO server AEC cards. The hardware on board is actually 50 milliseconds in tail length difference. So if you know that you have a challenging large acoustic space, it's always a good idea to design with server I/O as the core DSP there because of that extra 50 milliseconds. Just a pro tip note there on that side. We've also got better synchronization between the Biamp AEC and the Parley beam tracking algorithms. So since the Parley microphones are our Biamp product and they're actually sitting on the AVB network, we're able to set up back channel communications over that AVB network path between the AEC algorithm and the Forte or server DSP and the actual Parley microphone brain box out in the field. So the two of them communicate back and forth, and obviously that's part of Biamp's special sauce. They can coordinate with each other better and adapt as far as the tracking and synchronization. So that is helpful there. Moving on. Oh, actually, I forgot this one at the beginning. So if you have any questions, I want to make sure that you guys, you can go ahead and type them in the questions box, and I will address those at the end of the presentation as I'm able to. So go ahead and add those if you have them along the way. So moving on, TTM-X mute button logic. So with 3.17, we can now actually use the capacitive touch ring on the TTM-X as a logical input. So when you initialize that block, we select the 2-channel in this case as the example, TTM-X, and on this initialization window, you actually select the Use TTM-X button as logic box. And what that allows is the block now comes in with a B1 and a B2 on the bottom of the block, and that's button 1 and button 2, one logical output per respective microphone. Since this is a 2-channel or a 2 TTM-X block, we have a button for each mute ring. And that logical input node is actually a momentary logic and can be used programmatically as you need to within the Tesira file. So this will open up additional programmatic behaviors that you can actually configure when you're commissioning and designing Tesira systems with Parle TTM-X. As an example, design application, we're going to use this dual TTM-X system design, and there's some unique requests related to it. One of them is the system needs to mute post-AEC processing, and the second one is they want a 5-second press and hold that will power on and off the system accordingly. So if we look at those a little more specifically, the system needs to mute post-AEC processing. This is actually a throwback. If any of you remember back in the AudioFlex days, it's best to actually mute downstream of your AEC processing. And what this allows the AEC algorithm to do is to keep listening to the room and adapting, because AEC is an adaptive filter and we want to give it as much ear, quote unquote, to the room as possible. So muting downstream of AEC is recommended. As Parley microphones were launched, we didn't have tons of mechanisms without some kind of third-party control system to mute downstream. So muting most often happened at the microphone array block. Well, now with this, we actually are allowing logical button presses from the mute ring on the TTM-X to be used wherever you need to within the file. And then in this example, we've actually taken those button 1, button 2 logic mute rings, and we've run them into an OR gate. So if either one of them is pressed, the flip-flop will flip, and that then in turn drives a ganged mute within the Parle TTM-X processing block. What you don't see here is the AEC processing is actually on the front side of that Parle TTM-X processing block. It's just inside one of the first blocks there. And then towards the ladder mix output is that mute stage that we're muting. So flip-flop drives that mute, and then the mute output actually comes out and hits a NOT gate. And the NOT gate drives the color, red or green, on the input nodes on the top of the Parle TTM-X microphone. And then we've got a logic state, one channel logic state that turns on the LED as far as on or off. And that can be controlled as part of a preset or third-party control, contact closure, whatever you need within the system. So moving on, the 5-second press and hold for system power on and power off. You'll notice a lot of the logic is the same here, but we're actually taking that output of the OR and driving into a logic delay. That logic delay has been configured for a 5-second on. So after it senses a press and hold high signal for 5 seconds, it'll actually pass through a logic high to the flip-flop. And the flip-flop will drive an OR gate related to mute state that handles synchronization of the system on, power on or power off. And it also drives our system on, system off presets. So fairly simplistic solution there to allow press and hold for power system on and power system off. But as mentioned, you can use it for other things. You may want to say press and hold to call a camera preset to that location after 3 seconds. You know, it can be configured as needed for your specific system needs. So Tesira Software Improvements, this is actually, I guess, a smaller set of creature comforts is what I'll call them. In the equipment list, engineering has added the ability to sort and filter the columns, and you can also export the data to a CSV file. What does that look like? On this screenshot, I've got an equipment table of a system that hasn't been configured. I'm drafting at this point, and I've got 2 servers, an amplifier, and 2 control devices. You can see the little, what looks like a funnel to me, icon at the top. If you click on that, you get a drop down, and you've got values where you can actually filter by the boxes that are checked. In this example, this is actually pulled from a configured equipment list system at my desk. So bear with all of the crazy device descriptions and everything. But you can actually see, in this case, under the host name, you can go down and or expand that. And if necessary, you could check certain devices and have the list filtered for those. Or you can actually use your text filters. In this case, I've used the begins with filter and typed in Lux. So it filters the visible list to only Lux devices, because that's the text filter that I was looking for. These are, in most small to medium systems, these aren't going to be super helpful, but when you start getting into 20, 30, 40, 50 device entries in the equipment table, this filtration option and sorting option will really help you dig through and filter accordingly, and hopefully move quicker as you're programming and troubleshooting. Here's one more last screenshot, yet a different system, but I wanted to show here that there's an export button over in the middle right section there, highlighted by the green rectangle around it. But that actually allows you to export to the CSV and then import it or open the CSV file with Excel, and it gives me the same bit of information. So I think this is going to be most handy for post-commissioning as-built documentation. So in the process or project flow, you may order all the equipment, rack it up, commission some in the office, configure some of the devices in the office, and then once the site is deployed, once the system is deployed on site, commissioning and testing phase, you may have some changes in device descriptions due to location, etc. But once you're done, you can then export that information to the CSV, and that becomes something that can be handed over to the end user as part of the turnover documentation for system documentation, and or really helpful to any service technicians that may come out to the system in a year or two to service it. So really handy, again, kind of a creature comfort, but common format CSV, you can import it and read it in other programs other than Tesira. Similarly, the NCS block, so NCS block is network command string block. This is our now bidirectional control block that we added the bidirectionality back in 3.15, so back in May of this year. And we've added the sort and filter option here as well. In this example, I've got an MXA LED control network command string block that is configured. I've got commands that I send from the block or from Tesira from the block up top, and then down at the bottom we have expected responses, and that's the pattern matching portion, the bidirectional portion here of the NCS block. So when those strings are received, there's a pattern matching algorithm that goes on, and logical things or responses can be triggered accordingly. So the sort and filter was added to the response section, and you can see here that we can go through and select by checkbox which ones we want to filter for, or the text filters, which are probably more helpful here. And in this case, I filtered for a reply LED and then color. So we see only the 3 expected responses entries that are related to that particular string match. The Tesira EX-UBT, many of you are probably aware of this, but what is it? It is, at bare minimum, it is a USB audio extender over the AVB network, but it also has Bluetooth built in. It is probably our smallest physical size expander in the Tesira family. It's about the size of a pack of cigarettes or deck of cards, to give you an idea. And it hangs out there on 100 meters of cat cable and is PoE. So you can put this behind the display, under the table, wherever it needs to be, to connect a USB or add Bluetooth to a Tesira system design. The HID portion is the human interface device. So this is a host PC communications protocol, and allows the PC and the peripheral to communicate back and forth. And on the right here, you'll see the device manager. Up top, we've got audio inputs and outputs, where we have the echo canceller speakerphone. That's the EX-UBT that's showing up in device manager. And down below, human interface devices, you'll see in the middle of the list, we have a HID compliant headset. So it's using that human interface device for communication, communication channel back and forth between the audio peripheral and the host PC. We use that for mute synchronization on UC platforms. That's, again, a big part of the whole Microsoft Teams certification that we obtained. EX-UBT is required for that because of the synchronization of mute between the host machine and the Tesira system. We also use that for volume synchronization between the hosts. So, and it existed in 3.15, 3.16, but with 3.17, an adjustment has been made. So you implement this, it's only implemented on a speakerphone, so when speakerphone is enabled, but the range is now a little bit more limited. Previously, the range was -100 to 0, and we actually had a case or two where TTP, Tesira Text Protocol, was being used by a control system to track to this level range. And they noticed that when the host PC, the UC NUC PC, was used for volume ramping, the range looked different and the behavior looked different on the host PC than it did in the third-party control system. And we documented it, engaged engineering, and sure enough, there was a major difference. So previously, that range of -100 to 0 matches legacy Tesira blocks. So usually you have 100 to 112 dB of range control within the blocks in Tesira, and you can limit those down to whatever's needed. So the default for the USB block here was -100 to 0. So engineering actually did some research and started looking at things and realized, okay, well, when I have a Windows host PC and I ramp from muted and 0% all the way up to 100%, this is how it actually plots. It looks linear on the actual host machine, but it's actually doing this logarithmic jump from -100 to -60, and then all the way up. It kind of tapers its step size. Mac was a little bit more linear, but still had that logarithmic kind of slope to it. And then Chrome was straight linear. So 3 different platforms all behaving 3 different ways. So engineering made an educated choice here and said, well, -50 to 0 seems to be the most linear range in all of these applications, and 50 dB is pretty realistic as far as the applications that these systems are going to be used in. More than 50 dB range control is a little excessive in my opinion. So that's how they chose the -50 to 0 dB range, and with 3.17 and moving forward, that's what we have when we're in speakerphone. Legacy systems will maintain and respect their legacy configuration. So if you want to update an older system, I would say take that file, delete the old EX-UBT block, drop in a new one, and open it up, check to make sure the range is -50 to 0. And for demo's sake here, I snipped a video showing just the toolbar taskbar there of my PC, so you can see the level control and the opened dialog for the EX-UBT. So we'll go ahead and start that. So you can see it tracks, and at the minimum extent it mutes, and mutes in the Tesira as well. So I guess most common application here is going to be Microsoft Teams Rooms systems. So those user interfaces, the touch panels in the room actually do show the host PC volume range, and it starts up at a 50%. So that is actually going to be married to the volume level in the EX-UBT block within the Tesira file in the Tesira system supporting that room. So users' volume changes on the actual Teams Room system panel are impacting that level within the Tesira file, and you can see it from both sides, which is really nice. So bonus and overtime, a few additional resources here. So the TTM-X mute button is logic. That's actually a hyperlink there. That's been updated to our tips and tricks for Parley microphones article. We've also seen a recent uptick in requests or interest in camera tracking. So the Parley microphones, specifically TTM-X and TCM-X, have 4 zones or quadrants, and you can actually get information as to where the beam is within each of those zones. So we've recently updated the existing camera tracking section of that same article, the tips and tricks, and we've actually added a downloadable concept file that steps through and kind of gives you a concept approach for, I think it actually uses the TTM-X microphones. Most of those applications are going to be very specific based on the room design and the user needs. So that's why we call this a concept file, because it gives you the concepts, and then your specific application is going to be very unique. So feel free to call in and work with our support team on specifics of a system, and we'll try and guide you and answer any questions, help you set that up and just dial it into place. So it's kind of a massage thing. It depends on how the user wants it to behave, how quickly they want camera transitions and preset recalls. So that becomes very specific. And as long as you allot the proper time for commissioning, it really can be a pretty neat behavior in the system once it's commissioned well. Using the Tesira EX-UBT article, that one's been around since the EX-UBT launched. I added a few minor updates and the demo video that we just watched to that article, just stating that 3.17, it behaves a little differently. So you can view that there. Another thing that's not necessarily linked with the 3.17 release, but coincidentally, the timing aligned, but Tesira control modules have been updated on the Crestron application marketplace. So what used to be 3.0 modules, they're 2 years old at this point. They've been updated to version 3.1 modules for Tesira and Tesira Lux. There's also a supporting article, the Tesira version 3.1 control module deep dive is on the Cornerstone website, so feel free to review that. It's going to give you the brief detail on what changed and answer various behavioral differences or changes there. And last but not least, what's new in Tesira 3.15 video. So there's a link to the presentation back in May regarding quite a few features that were added. If anybody has questions about network command string block, there's really a good presentation and demo video, live demo video captured there that is on YouTube. So all of our webinars are actually archived on YouTube now. So if ever in doubt or curious, YouTube is your friend, and you can find our webinars archived there. So that's the end of the presentation. All right, well, thank you very much. Contact information's on the last slide here, support@biamp.com. That's our main number for technical support, and my email address there, Kris Daily @biamp.com. Thank you very much for attending today. Stay safe and have a good day.